All right, welcome ladies and gentlemen to Open Q&A week 29. My name is Brian McLogan and I am here to answer your questions that have been submitted. I hope you guys are having a great week and hopefully maybe you're starting to get yourself ready for school to get back into session, or maybe not. I was kind of thinking about it, like I haven't been back to school, actually going in there on Monday until, since March. So it's just kind of crazy to even think about the starting back the whole system. But my school is planning on going back into in-person teaching. And, at this moment, I'm planning on going back into the classroom as well as doing distance learning, as well. So that also reminds me, for those of you that are taking pre-calculus or having pre-calculus upcoming this year, just remember I will be back on my channel tomorrow night doing a pre-calculus training. That is the third training so far in the series, helping those of you that are taking pre-calculus go ahead and get started. I believe I have a link in the description for if you'd like to go and get my summer packet that I give to my students to get prepared for pre-calculus. And they'll just give you a good heads up what to expect and also really kind of build up those foundations. So I see Juan, Addie, Aiden, Luis, Elena, very good to see you. Thank you so much, guys, for joining in on the live stream. So if this is the first time you're joining in on one of my open Q&As, basically the way that this kind of works is I'm going to kind of answer some questions that have been submitted on the Google form that are in the description. So we're going to kind of handle a lot of different topics tonight. And then also you can get a little shout out if that is something that you are interested in. Happy to shoot out your guys' handles from there. And just a reminder, guys, I'm not able to get to everybody's questions. So if there is a question that you submit that I do not get to, it could be something that I just didn't have enough time to really kind of prepare for. Or you can also go ahead and submit that question onto Discord to go ahead and have a community like us go ahead and answer those questions. But before I get started into the open Q&A, I did want to thank all of you for all of your support and congrats on my channel I did finally pass the 500,000 marks. There's no gold play, there's no kind of like play button for getting half to a million subscribers, but it is a pretty cool feat. Definitely something I can say for the last 3 to 5 years since since 3 years since I've really been taking YouTube seriously, that I really did not even see in the horizon. And so it is really cool to kind of get up to that number, and also just kind of really like a disbelief, just kind of thinking about how many people have seen my videos and, or even just subscribed or liked my videos, or that I've been able to help them out with those videos. So it is kind of crazy, but I do want to thank you guys for supporting me, for all of you that, are joining me on the live stream, making comments. I'm trying to get back in to a lot of my comments. It's always tough to respond to so many comments, but I really try to make the best of effort as I can, at least some kind of sometime every single week to be able to get into the comments. But it was one of those reflections that people were, responding back to me, congratulating me for the 500,000. And I really started to think, if I want to get to 1 million, right? I don't really care about I have 1 million gold play button, but it really kind of made me think like that is the next milestone, right? That's where you're kind of like pushed to like have to achieve. But I just kind of started thinking, I'm like, if I want to get to that point, what I've done up to my channel, it's taken me 10 years to get to this point, right? And really most of my growth has happened in the last 3 years. But what I really started thinking about was last year, it's been really busy with me with kids, and I just have really had a hard time being able to respond to all my comments. But seeing everybody that has, really reached out to me and congratulated me on the 500,000, I thought, this is something that I got to make sure that I am continually being with the, community and giving you guys that value. And I think that the more value that you always give, then the more that you are going to obviously receive. And one thing that I really wanted to think about it, I get a lot of requests from students that are looking in for private, probably turn off my notification things. Want to look into students that are always looking in for private tutoring. And I mean, I probably get enough requests that I could literally quit my job and just become a private tutor if that is something that I wanted to do. But it's not something I want to do. I actually enjoy making videos. I enjoy still being in the classroom, and I enjoy coming on live, and answering your guys' questions, for free. But one of the things I did want to do is I wanted to give students that kind of personal touch and kind of aspect on the tutoring, because it has been a while. I used to do private tutoring. And, since I've had our kids, I really have kind of stepped away from that. Actually, yeah, it's been like the last 3 years I haven't done any private tutoring. So what I have decided is once I receive this 500,000 subscriber, then what I'll do is I'm just going to kind of open up my tutoring. But now, again, this is not going to be private tutoring. I'm not opening up anything where I'm going to have a schedule and my tutoring hours. But what I do want to do is still give people just that opportunity to have tutoring with me. And it's going to be something that I'm going to offer for free. And it is going to be kind of like a contest-driven kind of lottery kind of system. And every single month, I'm going to kind of open that up to do some different things. And maybe we'll increase that. We'll kind of see how this goes. But I think really giving, I like that one-on-one kind of tutoring relationship. And I really just, really appreciate all of the people that, continually watching my videos, are commenting, sharing my videos. And I think this is just one little small thing that I can do that I think can help some of you, And so what I'm going to do is I'm going to kind of run a contest for this first tutoring session on my Instagram channel. And if you have not gone to my Instagram, I am at Brian McLogan. You can go ahead and follow me there. And what I'll do is I'm going to put the instructions on Thursday for you guys to kind of know how I am going to be promoting for this in-person kind of tutoring session. So this will be a private tutoring session between me and you. It'll be online through some software that, probably like a Google Hangout. From there, and yeah, it'll definitely be something that hopefully you look forward to. And again, if you want to, participate and maybe you don't need tutoring, then you can always go ahead and share it to somebody else, or just give it back, and we can kind of go from there. So I just thought it was something cool, something I haven't done, especially online. I've done tutoring online, but not something I've done within the channel for all of you guys. So either way, we'll. If that is something you are interested in and you need some kind of tutoring, then feel free to check in on my Instagram on Thursday, and you guys will get all of the details. All right. And yes, we'll be covering most of the grades, but just for those of you that are maybe new to my channel, I mostly am going to cover or at least as a teacher, I have taught everything basically from Algebra 1 to calculus. But just like the questions that I get sent in, it's been a couple of years since I last taught calculus. So usually the calculus I need to do a little bit more preparing for. So it might be a little tough for me to do a private tutoring session on that, just because I wouldn't probably be, it might be a little bit more in depth or preparation than I'd really need to be able to have time for. But, and also statistics or physics, something like that. Those are two other courses that, again, it's just not something that I have readily available for and prepped for. So, but either way, we'll open up conversations. We'll just kind of go from there. And then again, even if you just want to hang out and chat for 15, 30 minutes, then that'll be cool. That'll definitely be cool as well. All right. So yes, there's Siddharth Manu. Very good. Well, thank you so much, guys, for joining in. Let's go ahead and get on with these questions. I kind of went through them again, but I'm just going to kind of just do another highlight here of the questions that I'm going to get to. And again, if you are just joining in on the live stream, you can go ahead and submit these questions to me every single week by going to the Google form and submitting the question. You can submit the question either by text. You can take a picture and send it in to me there. And basically, I will, on Sunday, I just kind of go through the questions and then promote or post, whichever ones I feel like I can be able to get through in a live stream. And then if I don't get to your questions, or if you just would like to kind of need like something immediate, you have a test, a quiz, or you just really want to know what the answer is, go ahead and go on the Discord server. The link is also on that Google form. And you can go ahead and post there, and people that follow my channel, calculus and above or below, basically just create a community of people helping each other with their math. So definitely something for you guys to check out. All right, so let's go ahead and get started with some math. So the first question was brought to you by @Vev, and they were asking to graph the 2x plus y is less than 1. So when graphing a linear inequality, we basically just want to think about graphing this like a equation. So basically, the easiest way to graph a linear equation is to go ahead and write it into slope-intercept form. So really, the idea we want to look here is to isolate the y. So what I'm going to do is I'm going to subtract the 2x on both sides, and then I'll have y is less than negative 2x plus 1. Okay? Now, we're not going to be concerned about if it's an equation or it's an inequality. We're going to play with that at the very, very end. What we want to be looked at, or we want to look at right now, is what is this going to look like? What is y equals negative 2x plus 1? Like, what would that graph look like? So y equals negative 2x plus 1. Okay, so if you remember, graphing an equation here, there we go, is 1 is going to represent the y-intercept. So that's going to be a point on the y-axis. And then negative 2 can be rewritten as a slope, m equals negative 2 over 1. Now again, that could be negative 2 over 1. That could be 2 over negative 1. Or, which is not preferred when graphing, you could write it as a negative 2 over 1. But again, we want the negative to be either in the numerator or in the denominator, because remember, slope, rise over 1. So are we going down to the right one, or are we going up to the left one? Well, it doesn't really matter, because they're both going to lie on the same line, which we call this the boundary line. So up to over 1. Okay, so you can see how they both kind of match up to the boundary line. Now, if this was a line, then I would just obviously draw a solid line. But you can see this is an inequality. And the inequality is important because when it's less than or greater than, that means the boundary line is not included in the solution. So therefore, to represent a line that's not included, we're actually going to use a dashed line. So I'm going to connect these points, but I'm going to connect them with a dashed line. And again, what that is just representing is that the line is not a part of the solution. Now, the next thing we want to do is identify, well, then what is true, right? Because when we graph a line, all the points that are on the line are true. Those are what satisfy the equation. But when we're looking for an inequality, we want to say, well, all right, for what points then satisfy this inequality? So what we need to do is use a test point. Now, the best test point to use, as long as your boundary line does not go through it, is 0, 0. So when I plug the 0, 0 in for x and y, I get 0 is less than 1, which is true. So here is 0, 0, and that point is true. So the nice thing about linear inequalities, if you have a test point and you find that one point is true and that point is below the line, that means all the other points below that line are also going to be true. You can test them out, and when we're doing instruction or something like that, I would show like multiple points. But in this case, I'm just going to be drawing those lines to show that all the points here below this line are going to be true. All right, the next question, the student had, if f of x is x squared plus kx plus 9 is greater than 0, then what is the value, or what could be the potential value of x? So this was my multiple choice question, and then I figured out the answer to be B. So the thing about this question is, if we know that this equation is greater than 0, right, then what is that going to look like graphically? Geez, that was a horrible straight line. Okay. So let's pretend this is the graph. If it's greater than 0, that means it's going to look something like this, right? The important thing is it doesn't cross the x-axis. It's above the x-axis, and it's always going to be going up, right? It's always greater than 0. Doesn't say, oops, sorry, did not say greater than equal to. It said greater than 0. So what that means is the solutions to this quadratic equation are going to be complex. So if I was going to look at the discriminant, right, that means b squared minus 4 times a times c has to be less than 0. Because remember, when the discriminant is less than 0, you're going to have complex solutions. So b squared here is going to be k squared minus 4 times 1 times 9. And that's less than 0. So I get k squared minus 36 is less than 0. Now, we could go ahead and add 36 and then take the square root. But again, that sometimes gets confusing for students to really kind of know like, what are the values here? So I'm going to forget about k being k, and I'm just going to think about what if this was like x, right? And I needed to like graph this. Well, if I was to graph x squared minus 36, like if I was to graph this line, y equals x squared minus 36, then that would be all the way down here. Okay, and that'd be 0, negative 36 would be the vertex as well as the y-intercept. This point would be 6, 0. That is the x-intercept, and then the other x-intercept would be right here. Okay, so if I was to look at this as an equation, I know I'd have those values. Now, when I look at this as an inequality, pretending k is x, just kind of using some substitution here, it says, when is k squared minus 36 less than 0? Well, that's going to be for all the values when negative 6 is when k is greater than negative 6, but less than 6. So the solutions that this student had to choose from, the only solution that fit that inequality was B, negative 5. All right, next question was brought to you by Hamad, was asking how to graph a cubic function when you are given the zeros. So a couple things that are going on here. We're going to want to understand zeros. We're going to want to understand multiplicity, and we're going to want to understand end behavior. Now, when we are graphing something like this, we could expand this. This isn't that crazy of a problem to expand. It's just going to be that's going to be a trinomial times a binomial. However, we don't really need to go to that element. Like we know, if I was to expand this, right, and then forget about even trying to do it in your head, we know that the leading term here would be an x squared. Actually, what am I doing? Actually, yeah. Let's just do that, but let's just do it to the other side. I got so much room. Okay. So if I was to expand that, but I'm not going to. All right. That's going to be an x squared. I know that that is going to be the highest degree if I was to take x minus 3 and then square it. Then if I was to multiply that trinomial times this binomial, again, I would get something like x cubed and then plus ... Because again, when you're trying to identify the end behavior, it doesn't really matter what everything is after the leading coefficient or the leading term, sorry. We just want to know what the degree is and the leading coefficient, right? We don't really care what the rest of the polynomial is when we're determining end behavior. So now we have end behavior, and hopefully you know that the graph is going to, based on this, it's going to fall to the left and rise to the right, all right? So now we have the end behavior. The next thing we can do to graph is define the zeros or the x-intercepts of the graph. So the zeros or the x-intercepts of the graph is going to be the values of x when y is equal to 0. So 0 is equal to x minus 2 times x minus 3 cubed squared. Well, now, since we have a product equal to 0, we can apply the zero product property. That's squared. Square root both sides. So here we get x equals 2, and here we get x is equal to 3. Now, it's very important, though, to understand that this 0 was raised to the second power. And that tells us the behavior of when the graph crosses the x-axis, which we call the multiplicity. And this has an even multiplicity, or a multiplicity of 2. So what that's going to tell us is the behavior of that 0 at the x-axis is going to bounce. It's going to behave like a parabola. Here we have x equals 2. That has a multiplicity of 1. That means it's going to behave like a line. It's just going to cross. It's not going to bounce at all. The other piece of information we can do is find the x-intercept. And so this is basically the zeros or the y-intercept. The the y-intercept, if you recall, is just what are the values of y when x equals 0. Well, this is kind of nice because when you plug 0 in for x, you get y is equal to 0. All right, so let's go ahead and graph this now. So what I know from right now is I have a graph that falls to the left, rises to the right. It has a y-intercept at 0. It has an x-intercept at 2. And then another x-intercept at 3. Okay. However, oh, thank you, Angelica. Just saw your nice little super chat. Well, that was very nice. Your videos, I have to go now take a little break. Your videos have literally saved me from my college math classes. Thank you so much for your informative videos. Well, you are very, very welcome. And thank you so much for joining in and providing your support. I really, really do appreciate it. All right, now back to regular station programming. But it is, thank you. All right, so in this thing now, basically we just got to connect these two end behaviors. But again, remember that this has to bounce, right? At 3, it has a multiplicity of 2. So if I kind of go from here, if it bounces, that's going to go like that. That one's going to, wait a minute, what the heck happened here? What did I do wrong? What did I do? Something is not right. What did I do? Oh, I'm an idiot. You don't know it's 0. Let's just plug in 0. No wonder. Jeez. I was like, that's not right. All right, we actually got to do this. So when you plug in 0 for x, that's going to be a -2. Sorry if somebody posts that in your chat. I'm like, -3 squared is 9. 9 times 2, that's a -18. That's way down there. Not that point, right? No. So therefore, you can see that, yes, that's how that graph is going to look. Okay, you can see that definitely it's going to be falling to left and it's going to be crossing. Perfect. All right. But yeah, you can see, guys, how, it's just a quick little thing. You're not even thinking about it, and you can make a silly mistake like that. All right, so the next question came in and finding the inverse. And we actually have quite a bit of inverse we actually have 3 problems on the inverse, so that will be pretty cool. And so if we need to find the inverse of a function, and we have it in function notation, which we have here, I'm just going to kind of go through the steps again real quick and not really get too in depth into it. The main thing we want to do is when you look at a graph of a function and its inverse, we know that the coordinates x and y are swapped as well as the domain and range are swapped. So therefore, we can first replace our f of x with y to represent the output variable. And 9 Universe, thank you, sir. I got A6 on my algebra final exam by watching your videos. That's awesome. Congratulations. Good for you. That is so cool. I'm so glad my videos, especially even algebra, like I got to redo a lot of my algebra videos. It's been so long since I taught it. And but that's awesome. Those videos have helped you out. And congrats to you for putting in the work and doing so well. So now getting into the y equals 3x minus 7. So we replaced fx with y. And now what we're going to do is we're going to swap the variables. So in this case, I have x equals 3y minus 7. It's just like swapping the variables on the graph, like the x and the y, the coordinate points, the domain and range, they all get swapped. And now what we're going to do is just go ahead and solve for y. So we'll add a 7. So we have x plus 7 equals 3y. And now just divide by 3. Okay, so you can just write this as x plus 7 divided by 3 equals y. And now you can just replace this with function notation. F of x equals x plus 7 over 3. And Simply P, thank you so much. Any advice for students struggling with memory? Simply P, I think if I was a student that I really struggle with memorizing things or doing like things, I think that was one point that I struggled with math was I always felt like I could never remember the rules. Like I'd always forget them and stuff like that. And I really do think that, just like with sports, sometimes math, we want students to have certain parts of information like readily available and be able to be applied when needed. So I think you can overcome that just like in sports with practice, just consistently doing some work. And again, it's not something that you need to be doing every night for 5 hours, but try to do 30 minutes every single day of just practicing, going over and over. And I think once you get that repetition of like 30 minutes, 15 minutes, just every day, just, get it in your calendar, your app, whatever, but just try to spend 15, 30 minutes, whatever you need of just practicing, reviewing. And I think that might be able to help what you are referring to as far as struggling with memory. And then also there's a lot of things we could go in much more depth, but to give you a quick little answer, that is one little tip. All right, so for the next one, we have and thank you very much for your super chat. I really do appreciate that. That is very generous, and I really, really do thank you. So for the next one, g of x equals 12 divided by x minus 2. So again, we're just going to follow the same process. Write that as y. So y is equal to 12 over x. Oops. Yep. Did I swap the variables? Yeah, I did. Okay. So let's go and swap these variables. So x equals 12 over y minus 2. All right, now this one's a little bit tricky. We don't need to keep the restriction because that was just kind of brought to us at the beginning. But now what we're going to do is we need to solve for y. Well, we can't solve for y when y is in the denominator, so we're going to get it off the denominator. So I'm going to multiply by a y minus 2 on both sides. So therefore I have a y minus 2. That looks horrible. So y minus 2 times x equals 12. Okay. Now again, we need to solve for y. But again, y is inside of these parentheses. That's being multiplied by x. So to solve for y, we need to get rid of the parentheses. Well, to get rid of the parentheses, we need to multiply by x. So we have yx minus 2x equals 12. Okay. And now I can go ahead and, what am I trying to do? I'm trying to solve for y, right? What the? No, what am I doing? I don't want to, I just need to solve for y. What am I doing? I'm going crazy. You don't need to multiply that through, guys. I'm going too fast. Okay, we got y off the bottom, right? We're just trying to solve for y. So guys, just divide by x. Crazy, Mr. McLogan. Y minus 2 equals 12 over x. And now you can just add a 2. There you go. So now I'll just rewrite this in function notation. G inverse of x is going to be 12 over x plus 2. There you go. All right, at Don Quince, it says solve using the square root method. Didn't give me an example, which you guys are possible to do on the Google form. But so the square root method is basically just like inverse operations with the square root. So the important thing to recognize here is when you are using the square root method to make sure that you include the positive and the negative value of your root. Because again, x squared equals 4, there's two answers there. Negative 2 squared is 4 and positive 2 is 4. So when we take the square root to both sides, right? Because we just want to use our inverse operations. All the square root method is just applying your inverse operations. So when I apply these inverse operations here, I'm just undoing squaring, which is the square root. And therefore, I just need to make sure I include, plus or minus 2. Okay? Because again, negative 2 squared is 4 and positive 2 is 4. And again, another way to look at this is you can always do the square root method. You could always use factoring. So I could do x minus 4. Maybe that's what I should have done. I'm going to change this one. Yeah. Do it that way. Yeah, you know what? Let's do this one. There you go. X minus 4 and equals 0, and then x squared minus 4. And then you could do factoring. X minus 2 times x plus 2. So when you can, on the square root method, a lot of times you can always rewrite them as, as a difference of two squares. And then you'd have x equals 2 and x equals negative 2 by applying the difference of two squares. So again, that works in this case as well. Like you could go ahead and factor this, but a lot of students would have maybe a little bit of difficulty of factoring this using the difference of two squares. So that's why it's important to just use your inverse operation. So if I had 2x squared equals 16 divided by 2, then I have x squared is equal to 8, right? Now I can take the square root. Now I can't take the square root of 8 like I did for the square root of 4. So now I need to break up my radical. So x equals plus or minus, and therefore I could break that up into 4 times 2. Well, now I know what the square root of 4 is. That's 2. So x equals plus or minus 2 square root of 2. All right, so then we also have bring into simplifying radicals. And then the last example is now going to be my, I have an expression raised to the power. But again, we're just using our inverse operations, right? I'm trying to isolate my variable x. So I'm just undoing everything that's being applied to the variable x, right? Add 16, divide by 2, then take the square root. Well, in this case, I have my x's being subtracted by 1, but it's being squared. Well, I cannot undo the subtraction until I undo the squaring. So I'm going to square both sides. So now I have x minus 1 equals plus or minus the square root of 7. Now I can't take the square root of 7, or at least break it down. I mean, it's 2.6457513, but I can't simplify it, any further, and I don't want to approximate it. So now all I'm simply going to do is just add a 1 to the other side. Therefore, x equals 1 plus or minus the square root of 7. Okay, so hopefully, square root of 7 is not a perfect square, but approximate 2.6457513. But yeah, then you can just add the 1 in and leave from there. All right. The next one was brought to us by Clark, which is, again, another inverse problem. So let's go ahead and just apply the inverse here. So f of x, so let's just rewrite that. Oh, let's just write that. Let's write that as y. And then let's swap the variables. I don't think I've ever done a problem like this. That's why I was like, oh, Clark, cool. Let's try this problem. So x equals negative. Let's see, square root of negative y plus 40. Okay, so now I need to solve for y. So I'm going to subtract a 40. So I have x minus 40 equals negative square root of negative y. Now to get rid of this negative here, I'm going to divide by negative 1. So I need more. No, let's keep that. So then I'll have a negative x plus 40 equals the square root of negative y. Now I need to square both sides. Negative x plus 40 squared equals negative y, and then divide by negative 1. So now I have an inverse function of f inverse of x is equal to a negative x plus 40 quantity squared. Now this is a problem because if you were to look at this function, that you would not get a quadratic. Like if you were to take this function and reflect about the y equals x line, you would not obtain a quadratic. So let me show you what I mean by that. Let's just kind of graph. Let's graph this question real quick. And again, let's forget this is 40. Let's pretend it's 4 just for simplicity's sake. So if I have a negative on the outside of the radical, that is going to reflect about the y-axis. If I have a reflection about inside the radical, that's going to reflect about the y-axis. And then I'm going up 40. So, or up 4, whatever. So basically that graph, let's see. So hold on. So looks like that, and then up 40. Okay. So the graph is going to be looking something like that. All right. Now, in this case, my point that I'm trying to bring in is you're not going to have, like if we look at this, we're not going to have a parabola here shifted. That's actually going to be shifted, let's say, to the right. So if you were to follow those transformations, you would factor that out. So that'd be a negative x minus 40, which would be 40 units to the right. Okay. But again, like that is not a reflection, right? So that doesn't work that way. So there's an issue here because this is not the inverse of that function. So what we need to do then is we just need to apply a restriction. And the restriction, if you look at this, is just going to be all values that are less than 40. So my restriction here is going to be x, which is less than 40. So I need to go, or less than or equal to 40. So I need to apply the restriction because if you don't apply the restriction, then you don't have an inverse. But now you can see as I remove that, I now have the inverse of that function. At least it makes sense graphically as well. All right, on to the last question, and then I will stay on and get under to you guys on the chat. So for those of you that are still on, thank you for staying on with me. And if you guys have some additional questions, I'll be more than happy to stay on and answer those for you as long as we have some time. All right, so the last question comes from Connor, which I believe, Connor, you might have made a mistake. If not, then I wasn't going to do your original problem because it would have taken too long anyways, just because I've done a lot of these solving rational expressions and you had plus 6x. And I think if that would have been the case, the problem would have been way too difficult, way too crazy for me to handle in the live stream. But typically I'm assuming that was just a written mistake from you because when typically we have these problems, first thing we're going to do is factor this. And if you had plus 6, the factors would be x plus 2, x minus 4. And we typically, to make the problem like manageable, we want them to be the same, or at least have a common, at least one of them to be a common denominator with our other two rational expressions. So if I factor this though, with a negative 6 instead of a positive 6, I get an x minus 4 and an x minus 2. Okay, so now what we need to do is we need to go ahead and eliminate our fractions. And we're going to do that by identifying the LCD, which is the least common denominator. So we have this denominator is x minus 4 times x minus 2. Over here, we have x minus 4 and x minus 2. Well, the common denominator that they all go ahead and divide into is going to be x minus 4 times x minus 2. So what I'm going to do is I'm going to take this whole expression and I'm going to divide it by x minus 4 times x minus 2. Okay, and what I'm going to do is I'm going to multiply every single term, every single expression by this x minus 4, x minus 2. And as long as I multiply everything by that, I'm not violating any principles of the equation. I'm still producing an equation, right? Because an equation is whatever you do on one side, just make sure you do it on the other side. So I'm going to multiply everything by x minus 4 times x minus 2. When I multiply this times this, the x minus 4s divide to 1, just leaving me with x minus 2 in the numerator. When I multiply this times this, the x minus 2's divide out, leave me with a x times x minus 4. And when I multiply this times this, the x minus 4, x minus 2's, they all divide out, just leave me with 2. So now you can see I have an equation that I just need to simplify and solve. So I'm going to apply a little distributive property. I don't really need these parentheses here. Okay. And now I recognize this as a quadratic. So what I'm going to do is I'm going to combine like terms and get everything equal to 0. Because for a quadratic, if I want to solve by factoring, quadratic formula, square root method, typically it's easier just to get everything to the same side, have it equal to 0. So what I get here is x squared minus, let's say 3x. Let's see, minus 2 equals 2. Subtract the 2. So now I have an equation, x squared minus 3x minus 4 equals 0. Okay, so now in this case, we just need to go ahead and see if we can solve it, find the solutions that make this equation true. Typically, we always want to look into factoring, which thankfully this seems to be factorable. And now I can apply the zero product property. Okay, so then I get x equals 4, x equals 1. And then last but not least, ladies and gentlemen, we just want to make sure that these solutions are not going to be extraneous. That means that these are not solutions to the equation that make our original equation, or make our original equation, or at least original denominators equal to 0. And thankfully, not thankfully, you can see that 4, when you plug 4 back in for x, you can see that 4 makes the denominator equal to 0. So this is what we call an extraneous solution. So the only solution, the only equation that makes this true is going to be x equals 1. And that is it. All right. So now I got a couple more minutes for you guys. I'm not sure if we'll get see whatever questions we have, but I do see you, Mohammed and Charlie and Laura and Anns and Meth and Lane Bud. Good to see you guys on. Thank you so much. So yeah, if you guys have any more questions, let you know. Just a reminder of a couple more. And also, Lou, thank you. I saw you at the beginning. Cheers for you, bud. And Nathaniel, thank you for joining in. You guys, just want to remind you guys, also for those of you taking pre-calculus, I will be going live again. I'm going to do a premiere. I like those premieres. I don't know if any of you guys have been on my premieres for my pre-calculus, but if you did kind of enjoy those, it was kind of nice because I mean, when I'm teaching math, like there's so much chat that's going on, I just can't get to it. Like, I mean, obviously that's why super chat is nice because it gives you a nice big bold color and I can see this super chat, you know, but it's pretty cool. Those premieres, if you guys have never been on one, I mean, it's a free, it's kind of like, it promotes it like a live stream, but the cool thing about it is I can really just like respond to the chats from you guys. So everybody that was on my premieres, I tried to at least say hi to them. And yeah, I was just kind of relaxing, watching my premiere and responding to the questions. So it was kind of cool. So I will be recording my next premiere and tomorrow, and then it will again premiere at 9. So therefore, we can go ahead and do that. Whiteboard there, and it's great. Do you have a voice chat on Discord? I do, but I'm not as familiar with that, and a whiteboard there, and it's great. That's a good idea. I guess I'll have to go and take a look at that. Whiteboard on Discord. That'd be cool if we can go and get that. I'll have to go and take a look. I'll have to go and look more into that. I haven't really looked into, like I've created it up because obviously for my upcoming class this year for pre-calculus, I'll be utilizing the Discord, and I use the private server for other courses that I'm a part of. But yeah, I haven't really looked into like different bots, on Discord that I could use, or really kind of other different features that students maybe would benefit from. So thank you. I'll definitely go ahead and take a look at that. Well, thank you, Nathaniel. I'm the biggest fan. Well, I very much appreciate that for you joining in. And Yolanda, use your videos before. Well, thank you. Well, that's awesome, guys. I really do appreciate you guys coming on. Lanebud did also have a question. How do you solve for 0 of x cubed minus 3x squared plus x plus 1? You would probably need to go ahead and use the rational zero test. I haven't done one of those problems. How much time do I got? I got a little bit of time. Let's go and take a look at this. I'd probably actually graph this before, but if you're not able to have a graphing calculator, plus x plus 1, what is that? 3x squared plus x. Okay, you could use the p over q to kind of see what is a 0. So remember, the p over q is going to be the list of all the possible constants over the rational zero. So it looks like the only possible p over q here is going to be plus or minus 1 over 1. So that's not really too much options. So we really have 1 and negative 1. So those are going to be your possible zeros. Now, it doesn't say that those are the zeros, but if you do have real rational zeros, it's going to be either 1 or negative 1. So then what I'll do with those is I'll just go ahead and use synthetic division. So I'll take the coefficients of there. If I have any missing terms, make sure you use a place value. And then I will just do synthetic division. I'm not explaining synthetic division because that will just take too long. And look at this, negative 1, that's 0. So that's a remainder, constant, linear, quadratic. So now I get x squared minus 2x minus 1. That is that is one of my problems. So this times x minus 1, as that is a 0, equals 0. So this multiplied by this gives me that, right? Well, now I can use the zero product property. I already had that, but right, we already know x is equal to 1. And then now I just want to see, well, what two numbers multiply to give you negative 1, but add to give you negative 2x. Well, it doesn't look like I'm going to be able to solve this via factoring, so I should use the quadratic formula. So my other two solutions are going to be opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And again, I'm just doing this very quick because it's at the very, very end of my live stream. So see, it's 4. That's going to be plus 4 over 2. Remember, we already talked about the square root of 8 is going to be 2 square root of 2. So x equals 2 plus or minus 2 square root of 2 divided by 2. And then you can just divide by 2 on everything. So it'd be 1 plus or minus the square root of 2. So there you go. Hopefully that helps you out. Charlie asks, what is my favorite number, pi, e, or golden number? I think I would say e. I like compound interest. So I think that is, yeah, I'd say e. And even though I do like the art of the golden number, I think that is very, very interesting and exposed from there. But I definitely would say compound interest wins it for me. 24/7. Perfect. My family are fans of yours. Well, that's awesome. I'm happy to have everybody on your family. I have difficulty with math word problems. Yeah, word problems stink. They definitely do. So, the main thing is to extract the math away from the word problem and then just kind of focus on what it is you're trying to accomplish, with the word problem. Set up the equations, identify your variables, solve the equations, and then just make sure your answer makes sense for the word problem. But yeah, I mean, it is a skill. And, it is something that it's not only a skill, but it also is, I don't know really what I was trying to say from there. But yeah, I mean, it is definitely a skill on top of the mathematics to be able to break down a problem and to do well on word problems, which, a lot of people are really good at math, but, they can really struggle with the word problem. So, it is something just like anything else, takes some practice and takes, some repetition and working through a lot. Santa says, take my pre-calc exam. You're taking a pre-calc exam. And my vids? No, thanks for the vids, but I'm still not going to pass. Oh, I'm sorry, bud. Hey, just do your best you can do. But I would definitely say do not go with that mindset. I know it can be tough, especially kind of going through and maybe, especially with the world and where we're kind of living in. And, I'm not sure how the course has been for you. But I can only imagine it was difficult even definitely under these circumstances. So, just remember that, one math course, one math grade does not define you or your situation, and, get back at it, and you can definitely learn math. You can definitely do pre-calculus. So sorry to hear you had a tough time, but I'm glad to hear my videos helped you, and then just stay at it. And do you have any current word problems, Brian, like the tailwind, headwind on your channel? Yes, I do. If you look at my vectors playlists, like applications of vectors, I do have some of those, plane with a wind and stuff like that. So yeah, just go and look at my pre-calculus videos, or just type in like vectors with my name and, vectors word problems. I have definitely some problems like that. Right. Thank you so much. I didn't know how to do the first step. Well, you're very welcome. All right. Do you have more problems on that? I think that is it. So, time for me to go, guys. All right. Well, thank you so much, guys, for joining me on the live stream. I hope you guys have a great evening or night or morning, whatever day of time it is for you guys in the world. And just a reminder for those of you that are taking pre-calculus, I will be back on my channel tomorrow night answering your questions and providing another streaming. Thank you again for all of you supporters on the Super Chat, as well as all you YouTube memberships. I forgot to give you guys a shout out at the beginning, but I really, really do appreciate you guys giving me the support and allowing me to make some more extra content on my channel. And I definitely have some more things that I am looking forward to producing for you guys and getting them out there. So you guys have a great rest of your day, night, or evening. And I will be back on tomorrow. And again, I will be back next week. So if you have questions, you want to know, if you have questions and you want to get them answered, go ahead and go to that Google form and I will do my best to get to you. All right, guys, have a good night. Oh man, I forgot to change that. All right, cheers.